Hi there, this is Mar Haddad here again. So in the first lecture, I want to speak about why we need to have IP version 6 and why actually we have IP version 6, because IP version 6 is already there. So why we do have IP version 6 in case we do have IP version 4. So for example, when you put an IP which is something like 192.168 dot something dot something, so that's IP version 4. So we do have IP version 4. Then why are we going now, and you see the world is moving to IP version 6? So that's a lecture just to explain to you why this transition is happening from IP version 4 to IP version 6. So if we look here for the IP version 4 address space consumption, and that's, if we look here, it is in 2008. So this is what the IP version 4 is, this whole picture. And you can see that it was not fully used. So IP version 4 was not fully used. And you can see that the one which have the yellow color are being allocated. That means they are being used. And the one which are available are the black one. And this one are unavailable, which are the red. So you see that on 2008, we were still having a lot of IP addresses to be able to provide on IP version 4. But if we look here, and this one is on November 30, 2010. So the second one, you see that is here, it's saying the date. So this one on 2010, you will see that everything is almost fully used. And that's 2010. We are now on 2020. So that's 10 years before now. So you will see that because of the growth of the internet and we're required to provide IP addresses to everyone to be able to go to the internet, then you will see that the consumption of the IP version 4 becomes too high. And then we don't have availability anymore for IP version 4. So that's again, it's in 2010. Now we are 2020, so I assume that this picture is much more than now. So it's almost full what we have now. So what happens is that all those IP addresses for IP version 4 have been already used, and now we still have a lot of requests for the internet. When we speak about internet, we say then it's IP version 4. Then that means in case we have more things to put the IP on them, so like servers or routers or so the company required to have IP version 4, and they want to request this from their ISP, and the ISP maybe will not be able to provide it. So we had a lot of things to be able to solve the problem, but yeah, this does not really solve the problem. Maybe it has delayed a little bit the problem of having the IP version 4 full for us. So before I speak about it, let me just tell you that the IP version 4, we know that it works on 32 bits. So we have 4 octets. That's the IP version 4. So in total, the IP version 4 can give us 4,294,467,296 addresses. So that's the maximum that IP version 4 can give us as addresses. And if you want to know how we can get this, so if I go to the calculator, and I can show you how I get this number. So we said that we have 32-bit, correct? And the bits can be or 0 or 1. So that's the base. So that means 2 to the power, we put it here to the power 32. Then this gives this number. You see, so this is the identical number. What you see here is this one. So that's the maximum that IP version 4 can give us. But that's not enough. So of course on IP version 4, you know that it has been divided into classes, class A, class B, class C, class D, and class E. So all of those things are basic. I assume that you already know about them. Now, to delay the problem of the IP version 4, because we know that the IP version 4 has been almost fully used. So there were a lot of things that were applied here, something like the VLSM, so which means subnetting. So we know that we had a lot of subnetting to be able to provide from the same network some subnetworks. So that's what is VLSM, variable length subnet mask. And also they deployed what's called the NAT or PAT. So that's network address translation or port address translation. That means that in case you have one router over here, and then you have a network which is here, that is the LAN. Okay, so you put one only public IP address here, and then you apply here the NAT or the PAT. And then in this case, all those here you can just put private IP addresses. You don't need public IP addresses. Privates that are free to use, so that's no problem. And then there will be nothing to be able to go to the internet. So that's again has delayed a little bit that the IP version 4 to go full, because then you only require one IP public, which is over here. So some customers like this one can get something like a /30 subnet. That means he has two usable IP, public IP, one on the router and one he can use it inside if you want to the server, and then he can go to the internet. So that has delayed really the IP version 4 to be full. But again, even with all those techniques, then IP version 4 is almost full. Now, someone can say, okay, now we know that IP version 4 is almost full, so why did we go to IP version 6? Why we didn't go to IP version 5? Because that's normal. IP version 4, then after that comes IP version 5. So actually, yes, IP version 5 is there, but it was used for an experimental project called Internet Stream Protocol. So you can see this is the project that the IP version 5 was used for. So yeah, if you want, you can have some information about it, about this project. If you want to read about it, I will leave this link for you. So the IP version 5 was fully used for this project. So that's why we had IP version 6, because IP version 6 had same function as IP version 4, is to provide IPs to the customers to be able to go to the internet. But IP version 5 was not possible for that because it was fully used for a project called Internet Stream Protocol. So as a review, we have now an idea that the IP version 4 is almost full. And we know that on IP version 4, there were some techniques to make the IP version 4 not full very fast. And those techniques were the VLSM, which is the subnetting, the NAT and PAT. So then you use internal private IP address to go to the internet, and you just have to put one public IP on the router to be able to go to the internet. But this has delayed the exhaustion of the IP version 4, but this has not solved the problem. So that's why we had to go to a new version of IPs where we can have much more IPs to be able to provide to our customers. Of course, this is the work of the ISPs. Now, we have also IP version 5, but IP version 5 was fully used for a project which is called Internet Stream Protocol, and then that's why we have the IP version 6 and not IP version 5. So this is what I wanted to explain in this lecture. Just an idea where we are now and what we have. Again, if you look now, this picture is from 2010 and it is almost full, and those pictures I took them from IANA, so we will know later what is IANA. So as you can see that in case we had only IP version 4, then we will end up having a problem, because we require, or the ISPs require, to provide IP addresses to their new customers, and with the shortness that we had on the IP version 4, that was not possible. So that's why IP version 6 came, and in the upcoming lecture I have to show you how IP version 6 became a successor for IP version 4. So this is what I wanted to show you in this lecture. I hope it was informative for you, and I will see you in the upcoming lecture.